Hi folks, welcome back. Mr. Ward, this is day 3, part 2. We got 3 more applications to do. We're going to revisit one like we did at the beginning of day 3 about the man walking in the shadow of the tower. I already drew this up because I want to just introduce you to a cool geometry concept that fits in really well. If I said I'm looking for x, here's what I would do, kind of what we did before. We found that theta. We used the small red triangle. I got it. So I would say tan of theta equals 6 over 15. Theta equals, that's why we're learning tan inverse function to find an unknown angle. And I found theta to equal about 21.8 degrees. Then I create a blue equation on the big triangle. Tan of 21.8 degrees equals x over the total of the big triangle bottom, which is 43 feet. Then I would find x by multiplying 43 by tan 21.8. And I would get 17.2 feet. However, it's a much quicker way if you use what are called similar triangles. And this is why we teach you concepts. What's true of triangle red? It's the same shape as triangle blue, it's just smaller. What does same shape mean? They are similar. The angles are the same. That angle is the same as that angle. That angle is the same as that angle. And of course, theta is the same as itself. And the sides are proportional. So I'm going to create me a proportion. I'm going to go blue. X is to 43 as. And proportions are great because as long as you set them up correctly, talk them through, they always work. Up and down is to bottom, as up and down is to bottom. And when I cross multiply, I get 15x equals 43 times 6. Divide by 15, what do I get for x? Exactly the same. Didn't even need any trigonometry. So, if you went the long way, that's fine. We could have done it the other way. All right, 2 more applications, both pretty cool. One of them we're going to use to calculate how big the sun is. Kind of cool question. It says, use a transit that measures angles. People use it who are into land surveying. And they said the sun fills up 32 minutes of arc. Not even 1 degree, very small. And that makes sense if you looked at the sun, it's so far away. It wouldn't be very big. Assuming the sun is 92,919,800 miles away, use that to find the diameter of the sun. Well, what I'm going to do is I'm going to actually find the radius first. So I'm going to put an X there, and then I'll just double it. And what do we know? This whole angle is 0 degrees 32 minutes. So half of it is 0 degrees 16 minutes, not even 1 degree. And we know the radius, we know the sun's distance from Earth, because this is Earth, is 92,919,800 miles. So look at that right triangle at the top. We've got an angle, we've got an opposite, we've got an adjacent, which means we're going to use tan. And to find x, we're going to multiply. And just to remind us how to do this, let me show you on a calculator here. I think I might have it already. If I don't, yeah, I do right there. 92,919,800 times tan of 0 degrees. And I use that second angle button. I'm going to write it down and then I'll show you the step again. X equals 432,471.5 miles. Second angle. There's your degree symbol in 1 and there's your minute symbol in 2. And if I multiply that by 2, what's roughly the diameter of the Earth, of the sun, pardon me? 864,943 miles diameter. Got it. Got it. All right, last question. Probably the most challenging we'll do because it gets into this thing of navigation a little bit. Don't worry about it. We'll do the best we can. It says, a private plane flies 1.3 hours at 110 miles an hour on a bearing of north 30 east. I need to draw that. So first thing, I need to think about where north 40 east is. And the answer is, it's in quadrant 1. Northeast is in quadrant 1. Okay? And that means 40 degrees to the east of due north. 40 degrees to the east of due north. So I'm going to draw north. I'm going to go 40 degrees to the east of it. And I'm going to draw the plane's path. And I need to convert this to a distance. Distance equals rate times time, 110 times 1.3. That distance is 143 miles. The plane then changes direction to south 50 east for 1.5 hours at the same speed. So distance 2 is 110 times 1.5, which is 165 miles. So that's going to be our new length. And the the direction, southeast, that's going to be quadrant 4. And it's 50 degrees east of due south. So I like to do it this way. 50 degrees to the east of due south. And that length is 165. What am I going to need to find? Two things. Number one, what the distance home is. And number two, what the bearing is to get home, the angle. So the first thing I got to do is look at that blue, red, green triangle and figure out how am I going to find that. Okay? Starting right here. Another geometry concept, very cool, is I see a Z. This here, and this here. So therefore, if that's 40 here, that's 40 there. Okay? And 40 and 50 make 90. So that is a right triangle that I can use the Pythagorean theorem on. So if I want to find x, I would do that. And again, I can use trig if I wanted. I'm going to use Pythagorean theorem. 143 squared plus 165 squared. And I get something like 218.3 miles to get home. And if I wanted to find the heading home, I could find this angle right here, which is, let's see, that would be theta. 165 is opposite, 143 is adjacent, so I could say tan of theta equals 165 over 143. That's why we have inverse functions. Tan inverse 165 over 143, which I got to be 49.1 degrees. And remember, that's what this green one is. So if I add that 49.1 plus the 40, what am I doing? 89.1 degrees. If I went from an airport to plane, I'd be headed northeast, but I'm going from plane to airport, so actually I'm going southwest to get back home. So that would be this angle right here. All right, that's a challenge, but things we can do, we'll spend more time on that. Great applications, things that we use trigonometry for. Definitely something like navigation, okay, orienteering. All right, got through it pretty quick. That's the end of day 3. Again, it's part 2. Next day 4 is on harmonics. Have a great day, folks.